Hi everyone. In today's challenge, we are going to solve this problem. The problem name is maximum level sum of a binary tree, and the problem number is 1161. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine, guys. Now let's understand this problem statement, right? So problem says, given the root of a binary tree, the level of its root is 1, the level of children is 2, and so on. So let's draw a binary tree, right? So binary tree, let me draw it here. So I'm just drawing it randomly, right? Fine. So guys, what it says that we are given first of all that the level of root is going to be always 1, right? After that, the level of its children is 2. So the children of root is nothing but this and this, right? So we can say level of this is 2 and 2, and the level of this we can say root, we can say the children of this or we can say node is going to be 3, right? So this is going to be 3, and the children will also going to have 3 of this particular node, so we are going to say this is also 3. So guys, this is going to be 4 4 4. So we can say, guys, the first is nothing but by this we can assume that, or we can clearly see that this is going to have a level 1, and this is going to have a level 2, this is going to have a level 3. All the nodes on this line is going to have a level 2, all the node in this line is going to have a level 3, all the nodes in this line is going to have a level 4. Now we can also pronounce like this, that on the level 1 nodes are these, on the level 2 nodes are these, on the level 3 nodes are these, and all the level 4 nodes are these, right? So now after that, what it told us that return the smallest level x such that the sum of all the values of the node at level x is maximum. So guys, what we have to do, we have to find the smallest level. See guys, smallest level, but such that all the values of that node, if we have to sum all the values of that node, that should be the maximum from all the levels, right? So you can understand this thing in example one very clearly. You can see here, guys, we have this one, right? So we have this root 1, so this is level 1, this is level 2, all the nodes on this line is going to be have level 2, this is level 3, right? Simple. Now what we have to do, we have to see the on level 1, the what is the sum, that is 1, right? Here is the 1. What is the sum here? Here is 7. What is the sum here? Here is minus 1, right? Now guys, can you tell me the maximum sum where it is present? It is present on level 2, right? So we have to return 2. And now they also told we have to find smallest level. So guys, if it's there somewhere exist some, also we can say 7 only, right? If there is exist, let's say on level 4 also we are having a level, we can say sum is 7, so we have to return 2 only. Why? Because we have to find the smallest level which have a maximum sum. I hope you are getting it, right? First thing is we have to find the maximum sum, which level have a maximum sum. If there are more than one level exist which have a maximum sum, so we have to return the smallest one. It's simple, right? Now let's move to the example. This particular example we have already understood, but let's move to the implementation or logic part, not implementation, so that we can understand how we can solve this, right? So logic part is going to be really easy, guys. First of all, you must have a clear idea on the, we can say this problem understanding part. You must understood the problem. What we have to do, we have to just find the smallest level such that the sum of that sum of the values of all the node on that level should be maximum, right? So on the logic part, what we are going to do, we are going to define this only, and this logic is not going to take a much time, guys. It is a we can simple, we can say a simple algorithm. We are going to use it, and we are going to simply solve this problem. So what we are going to do, guys, actually here we can see that we are going to traverse level wise. Firstly, we are going to traverse on this level, then we will traverse on this level, then we will traverse on this level, and on each level we are going to keep record of three variables. First is result, which we are going to return. Second is level. Third is current, maximum sum, right? These three things we are going to we can say carry on while traversing all these. So first time we are going to say maximum sum first time is going to be a negative one, right? Now first time we are going to at root 1, right? On root we can say level 1. So we are going to say fine, you are at level 1, find out the sum. What is the sum of all the nodes, or sum of all the values on that particular level? So you can see here is only one nodes, so we are going to say 1 is the sum. So is this we can say it is, let's say, minus 1000, right? Anything. So is it greater than maximum sum? Yes, it is greater than maximum sum. So insert this thing over here and insert the result to, we can say, the level this, which is the level this is the level 1, right? So we are going to do this thing on this particular example. So we are going to see how we can do this, right? So I'm not going to tell here, I'm just going to explain with this example. So let's go through this, right? So first thing we have told that we are going to have let me take a different color. We are going to have this variable result, which is initially 1, level also initially 1, and also we can say maximum is initially minus 10 raised to power 5, right? Why? Because they have given a constraint, right? Now what we are going to do, we are going to traverse level by level. So we have traversed the first level and we go to the sum is nothing but 1, right? So on first level you can see we have only one node and the value of one node is that node is nothing but 1. So we are going to say it is 1. Now we are going to check if this current sum is nothing but sum of all the values of that particular level. So if current sum is greater than maximum, yes, it is greater. Current sum is 1 and maximum is minus 1000, 10,001. So we can say fine. So now make a maximum is equal to that current sum. Means now we are going to say our maximum is nothing but this current sum, because so far we have got the maximum value is 1. So we are going to modify this and we are going to write it 1. And after that what we are going to do, we are going to say fine. Now make a result is equal to level. And what is that level? Currently we are at level 1, right? So result is not going to update. It's even though it's updating, it's not going to affect it, right? So we are going to say result is going to be nothing equal to 1. Fine. Now let's move to the level 2. So on level 2, we have find the current sum is nothing but 7, right? On current sum is 7. So is 7 is greater than maximum? Yes, 7 is greater than maximum. So now update a maximum to current sum, which is going to be equal to now 7, and update the result also equal to level 2, right? Result is level 2, and level was already 2, right? So we have seen now result is equal to level 2. Now we come to level 3. On level 3, we found a current sum is nothing but, and let me update here as well. Now we have to find the current sum, which is nothing but equal to minus 1. Is minus 1 greater than maximum? No, maximum is 7 and minus 1 is current sum is minus 1. So current sum is not greater than maximum, right? So this condition is never going to run, and we are going to come out to the next level. And you can see there is no next level exit. So we are going to come out from our, we can say, traversals, and we can say simply return result, which is nothing but 2. I hope this makes sense, right? We are going to just use a breadth first search. So this is nothing but BFS, breadth first search, which traverse level by level, right? I hope it makes sense, right? So now let's move to the implementation parts. Let's see how we can implement this in Python, C++, and Java, and there you will have a better understanding how this particular logic is going to work, right? So let's move to the implementation part. So guys, I'm here first of all with Python. What I'm going to do, I'm going to say first of all, just first of all, we can say make a result which is initially 1, and then you have to make we can say maximum, right? And you also make a level, so we can say like this, and result is 1, level is 1, maximum is, let's say, minus 1000, or we can write like this as well, floor minus infinity, right? In Python it's work, it's going to take a max infinity more minus value, right? After that what we have done, this thing, we are going to say uh, take a queue, right? For BFS what we do, actually we use a queue. So queue, and here we can say collection.queue. So we can say our queue is going to be nothing but equal to collection.tq, and here we can pass initially root, right? Because they have mentioned in the, we can say, constraint that there will be at least one node present. So always remember the constraint, right? Once this is done, we are going to say 4, or we can use a while loop. While queue exists, that means there is a node exists in our queue. So take out first of all size of queue. So we can say n is equal to length of queue. After that you can say 4 underscore in range in n. What is going to tell us that n is going to tell us that how many nodes are present on that particular level, right? So we have to take out all the nodes and we have to sum them. So node is going to be equal to q dot op left, right? Once this is done, we are going to say let's make a current sum variable as well. Current sum is 0. So we can say current sum is going to be updated, current sum plus equal to node dot value, and here we can say if node dot left exists, so you have to say q dot append node dot left. Let me write here this. And if node dot right exists, so you have to append that particular thing as well. I don't know what is happening here. All right, so q dot append node dot right. Fine. Now once this is done, we are going to come out from for this loop, for loop, and by this means that we have already calculated the sum of all the nodes on that particular level. Now what we are going to do, first of all check. We have to check if current sum is greater than maximum. If it is so we can say maximum should be equal to current sum, and level should, or result should be equal to level. And after that we have to increment our level. We are going to move to the next level, and after that we have to return our result. Let's try to run this code and see whether it's working fine or not. And I hope guys it should work, right? And you can see guys both the task is passed. So let's try to submit this code, right? And here we go guys, right? So it's successfully submitted. Now let's move to the next programming language quickly, which is nothing but C++. So what I'm going to do, I'm going to quickly define first of all result is going to be nothing but equal to 1, level is going to be equal to 1, and maximum is going to be nothing but equal to minus, we can say like this, right? After that, what we are going to do, we are going to say let's make a queue which is going to be have a data type tree node. All right, and the name I'm going to give is nothing but q only, right? And here we can say while q dot empty, right? Well, q dot empty means until and unless q is not empty, keep running this loop, right? So what we are going to do, nothing, what we are going to say, we can say first of all take out the node. First of all, tell me the size, how many node present on that particular level. So we can say int n is going to be nothing but q dot size, and here we can say for int I is equal to 0, I less than n, and I plus plus, move to all the nodes, and here we can say first of all take out the node, so which is going to be nothing but tree node, that right here tree node, and the name I'm going to give is q node only, so it is going to be nothing but q dot front, right? It's going to give us a node, and after that we have to pop it from the queue. Once we have done this, we are going to add in our current sum, and current sum variable we haven't declared, so let's declare current sum which is initially 0. Now we can say current sum is equal to plus equal to node dot value, right? Fine. After that we are done this thing, we are going to say check it if node dot left exists. Node dot left exists, so what you have to do, you have to say q dot you can say push that particular node dot left, right? And we don't use a dot operator in C++, so we have to use this arrow operator. Fine. Same we have to do for right side as well. Node right, and here we can say q dot push node right. After this, we are going to say come out from this for loop. We have to check if current sum is greater than max sum. If it is so, then you have to make max sum is equal to current sum. And one more thing you have to do, which is nothing but we can say you have to make result equal to level. After that, we can say increment your level by 1. And after that, we can say simply return our result. So let's try to run this code and see whether it's working fine or not. Or do we have any mistake in C++? Let's check it. So it's taking a time, that means we haven't done something wrong here. Alright, so it's nothing but here only saying that no member empty is present in this particular queue. Why is it so? Alright, so we have to insert something in queue as well, right? So we have to say q dot push and that particular root as well, and it's saying that no member, right? So we have to check that thing. No member named empty is in the standard queue to queue allocated tree. So let's try to run this code again. Alright, so there is a spelling mistake, empty. Now let's run this code. And yeah, by the way, we have to also insert root as well, right? Initially, otherwise it will be never run, right? Fine, let's run this code. And you guys can see that both the task is passed, right? So let's try to submit this code as well. And here we go, guys, right? So we have successfully submitted with C++ as well. Now let's move to the last, which is nothing but Java programming language. And here we can say first of all result is 1. Let's write here 1. Level we can say also 1, and we can say max sum is going to be nothing but minus 10 5. And here we can say make a queue, so we can say queue in, we can say tree node, right? Tree node, here we can say name is queue, which is going to be equal to new linked list. And after that, what we are going to do, we are going to say insert this in this queue, queue dot add. What we have to add, we have to add our root. Now you can say while this queue is not empty, right? So we can use a not operator. While queue dot is empty is false, means there is at least single element node present in our queue, so keep moving, right? Tell me the size first of all. So q dot size. So in the size we have to traverse only on that nodes in that level. So for int I is equal to 0, I less than n, I plus plus. Let me use a small n. And here we can say if first of all we have to take a node, right? So we can say tree node is equal to q. Let me use this front, right? Once this is done, we are going to say fine, it is done. Now what you are going to do, instead of front we can use a remove as well, right? Alright, so now what is once this is done, we are going to say okay, first of all add this into our current result. So we are going to say int current result, or current sum is going to be initially 0. We are going to say current sum is equal to plus equal to we have used a tree node, but we haven't used that particular name, right? Node dot value, right? Now we have to check if node dot value is not equal to null, so we have to say q dot, we can say add this node dot value. Same we have to do for right side, not value. Left, it was for left side, it is for right side. So if right side is also not null, means it has a right no children. So you have to insert that also in your queue, right? So you can say queue dot add no dot right, right. Once this is also done, we are going to come out from this for loop. We are going to say check out if current sum is greater than max sum. You can say max sum should be equal to current sum, right? And after that, you can say result should be equal to level. After that, you have to increment your level by one, right? Because you want to move to the next one. After that, you can simply return your result whenever this while loop will open, right? So now, guys, let's see whether it's working fine or not, right? I hope it should work, right? No, it's not working because only we haven't used a semicolon, and I don't know why I'm missing this particular thing. All right, so I think it should work now, right? It's taking a time. Maybe something is missing. Again, a semicolon. It's not a Python. We have to use it, right? All right, so I hope, guys, now it should work, right? Let me see both the test case pass. Yeah, here we can see, guys, both the test case pass. So let's have to submit this code as well, and it should get submitted. So finally, guys, it also got submitted. So we have successfully implemented our logic in C++, Java, and Python. We have also understood the problem. We have also understood the logic part. If you have any kind of doubt, we can say in any of these three part, logic part, understanding the problem part, and this implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.